Day 1 of solving random physics problems until you understand everything in your physics syllabus. Let's take a look at the problem. An object is released from rest and slides down a frictionless ramp. The object then leaves the ramp and slides along a rough horizontal surface. The object stops in a distance s along the ramp. The coefficient of dynamic friction between the object and the rough horizontal surface is mu. What is the height of the ramp? So to deal with problems like these, I'd like to use the conservation of energy principle. Since the object is at rest and since the object is at its maximum height, the object will only possess gravitational potential energy. Gravitational potential energy is denoted as mgh, where m is the mass, g is the gravitational field strength, and h is the height of where the object lies. And right now, this is the total energy of the object. Then, when the object slides down, it will gain speed and lose its height. So at this point right over here, the object will have only kinetic energy. And by that means, the entire gravitational potential energy will be converted to kinetic energy at this point right over here. So the total energy of the block right over there becomes its kinetic energy. I'll label this point 2 and this point 1. So at 1 it's like this, at 2 its energy total is equal to kinetic energy, and which is denoted as mv squared over 2, where v is the velocity of the object at that given point. And so since we have energy total right over here and energy total right over there as well, we can equate them since they're the same thing. mgh is equal to mv squared over 2. And so m's cancel out over here, and the velocity is given by square root 2gh. This is going to be the velocity at this point right over here, the velocity of the block. Then what do we know? We know that this surface right over here, since the object has a speed right over here, is still going to continue traveling through this surface right over here. However, this surface is rough, meaning that there is friction and dynamic friction. Dynamic friction is a friction that is acting on an object while the object is at its motion state, so it's moving. And so this friction is going to cause our object to decelerate and eventually come to a stop. So we know that the friction force is given by this equation right over here. Here, the coefficient of dynamic friction multiplied by the reaction force. And it's given that our dynamic friction right over here is going to be mu. Our reaction force is simply the force that is being exerted on our block. For instance, when our block is right over here, the block has its own weight, which is mg, and the reaction force is simply the same force that is reacting in the opposite direction, so that will be mg as well. And so we have mg as our reaction force. Our friction force is acting on the opposite direction, is acting on the negative direction. So we'll take this direction negative and we'll take this direction positive. So here, we're just going to put minus sign. According to Newton's second law, we can say that this all equals to ma, where a is the acceleration. The